Hello everyone, this is Rajat from IIT Bombay. Today we'll discuss question 21 from GATE 2020, where we have to find the resonance frequency of F19F nucleus in the presence of a field of 16.45 Tesla. And the parameters that will be useful for these questions are G factors for 19F, beta n, and H, the Planck's constant. We have to comment the frequency at megahertz unit with a rounding up to one decimal place that we have to keep in mind. Now, to answer this question, we have to know the basics of NMR spectroscopy and the relation between the frequency and the parameters given. Now, to start with, we can continue with the thought of a magnetic dipole moment where a particle of mass m and charge q is rotating through this circle of radius r with the speed of v. In that situation, the current that will produce is nothing but q by t, where q by 2 pi r by v. That is the time required to complete one circle, and the final formula of I equals q v by 2 pi r. And as you know, area is nothing but a pi r square for the circle. So the magnetic dipole moment becomes current into area, which is qv by 2 pi r into pi r square. The final form is look like something qvr by 2. And now that v can also be replaced by its relation with angular momentum L, that is ml equals to mbr. So v becomes L by mr. So if we replace that part there, we'll get that qr by 2 into L by mr, and the final form looks something like this, ql by 2m. As magnetic dipole moment itself is a vector unit, and the right hand side only one vector unit, that is L. The final form in a vector form, the final equation in a vector form will look something like this: m equals to q by 2m into L. Now, this is a concept with thinking of a particle of mass m. If we just take this concept and use that on a nucleus, we have to substitute some parameters with some known thing regarding the nucleus. First of thing is we have to replace the charge q by gn e, where e is nothing but the charge of one proton, and gn is known as the gyromagnetic ratio or magnetogyric ratio, which take care of the compactness of nucleus that contains the number neutrons and protons that are there. The mass m has been replaced by mp, that is the mass of proton that are there to produce the current or to interact as a magnetic dipole moment. Angular momentum L by I, which is known as spin angular momentum, which depends on the number of nucleons present in the nucleus itself. So the final form will look something like this, where m becomes equals to gn into e by 2 twice mp into I. Now, when we apply some external magnetic field B on this kind of magnetic dipoles that are produced, then the energy up with the interaction of the magnetic dipole B, magnetic field B is become minus m into B, where the minus stands for the stabilization energy that is there. Whenever they are in the same direction, the direction of the magnetic dipole moment and the applied magnetic field, E becomes negative. If they are not, E becomes positive. So let's substitute the value of m that is there, and we got to know that if the angle between the magnetic dipole and B becomes theta, so I dot B can be replaced by I magnitude of I into magnitude of B into cos theta. Now this I into cos theta can be considered as the Z projection of I, and that's why it can be written as IZ. So the final form becomes minus Gn into E by 2mp into Iz into B. Now, by quantum mechanics itself, this Iz has some restricted values, and let's say from minus I to plus I, something like that, and that's why let's substitute that part with my mi into h cut. Now the E value that will be there will look something like this, and you can see after substituting the value of Iz by mih cut, we found a new constant value that is there, eh by 4 pi mp, and can be written that part as a simple form of beta n, which the beta n is known as the nuclear magneton. If we now see the both sides, energy itself is related to the parameters of Gn, beta n, Mi and B. Now B is applied field strength and it will be a constant for a specific NMR spectrometer. Gn and beta n itself constant, Gn dependent on the nucleus that we are talking about. Beta n is a universal constant for all kind of nucleus that are there. So E is only dependent on the Mi value that is there. So that if we want to find the energy difference, del E becomes minus Gn beta n B into del I, where the LMI is the difference between the two consecutive states. Now, if we go through different I values, let's say for I equals to half, the consecutive states are Mi plus up to Mi minus up. So del Mi, this situation will be equals to 1. Let's go to, if we go to I equals to 1, in this situation also it will be Mi plus 1 to 0 to minus 1. So the consecutive states has a del Mi difference of 1. If you assume I equals to 3 by 2, in that case the states will be minus 3 by 2, minus half, plus half, and minus plus 3 by 2. There also the difference will be equals to 1. So we can replace this del Mi as equals to 1, and in this the formula will look something like this. And just to relate that with h mu, we take a modulus of that. So h mu becomes Gn beta n B, and mu, the final form, becomes Gn beta n B by h. That is the formula that we require to answer the question that is given. Let's go to the back to the question. We need the value of B, that is 16.45 T factor. So Tesla G factor is given by 5.255, that is the Gn for our question. Beta n is also given and h is also given. Let's substitute all these values into the equation. So the equation looks something like this. We go to that with that joule, and that this joule will be cut off, Tesla inverse, and Tesla will go. So ultimate unit of all those things becomes second inverse, and the value will become 65.884 10 to the power 7 second inverse. And second inverse is nothing but hertz. We have to write the last result at megahertz unit. So we take 10 to the 6 from this part and multiply the rest of the 10 here. So it becomes 658.84 into 10 to the 6 hertz, that is the megahertz unit. And now we have to report the value up to 1 decimal place. So the final result will be 658.8 megahertz. The reported result for this question is 658 to 6 in value between 658 to 659. That will be the final result that you accrue after all the calculation. I hope this solution that is there is helpful for you people. If you want to know more about the basics of basic principles of NMR and about instrumentation, you can follow the link here to a lecture by Professor Saugat Hazra of Department of Biotechnology, IIT Roorkee. That's all from my side. Thank you.